Just doing a mic check. If someone can let me know in Discord if they can hear me okay. Awesome, thank you. So we're starting at 5 past today, just to give students time to get here if they've got another class on before this one. Okay, it's 5 past, so we'll get started. Welcome to Thursday, week 7 of ENGG1003. I think it's been a big week for everyone with the assignments due this week and currently being marked. So hopefully everyone did as well as they hoped with those. So today we're going to build on what we saw in the Monday lecture. So in the Monday lecture, we saw about two-dimensional arrays. And today we're going to take those arrays and show how we can use them to create images and to process images. And we'll be looking at mostly two-dimensional and three-dimensional arrays today in the lecture. Okie dokie. So two-dimensional arrays we'll use for black and white images or grayscale images, and three-dimensional arrays we'll use for color images so that we can specify the red, green and blue components of each pixel. So this is the first set of code, and this is the code I'll be working through in the first couple of slides in this lecture. This code should be available on the Discord channel lecture code if you want to start playing around with it. But I'm going to go through each part one bit at a time as we go through this lecture. Now, the first two lines should be fairly straightforward to you. We've been using them, excuse me, for a long time now. We're going to need the matplotlib library, and we're going to use the NumPy libraries for the lecture today. So we have to import them. Now, the next set of lines is what we're going to do is we're going to create a two-dimensional array M. And we've already seen this in the lecture on Monday. We're going to use the NumPy function zeros. And we're going to create a 10 by 10 array, which means 10 rows and 10 columns. And we're going to create an array of integers. So this is this int parameter into the zeros function. All right, so this is my 10 by 10 array M. But I'm not going to leave every entry 0 because that would just be a boring array. What I'm going to do is I'm going to put a cross shape of ones in the array, and that's what these two lines are doing. So what I'm doing here is in my array M, for rows 4 and 5, remember that when we do this kind of slicing, the first number is the start row or column, and the last number -1 is the end row or column. So what I'm doing here, I'm saying take rows 4 and 5, all columns in those rows, and create that entry to be 1. So this is how I get this row of 1s in my matrix and this row of 1s. So this is row 0, row 1, row 2, row 3, row 4, and row 5. So I've put 1s in those rows. Then in my next line of code, I've said take columns 4 and 5 and all rows corresponding to those columns and put a 1 in all of those entries. So this is how I've got this column of 1s here and this column of 1s here. So all I've done with these 3 lines of Python is create my 2-dimensional array M, which has 10 rows and 10 columns, and which has some entries in it, which is 0, and some entries in it, which are 1. So how do I turn that into a picture, an image? And I'm going to do that using matplotlib, which is a library we're very familiar with for creating plots in this course, but it can also display an image. And the pyplot function imshow or imshow is the function we need to use. And the argument to imshow is just the matrix that we want to create an image from. And what that function does is it takes every entry in that 2D array M is a pixel in the image. So this is the first pixel, second pixel, so on and so forth. So it translates that NumPy array into an image where each entry in the NumPy array is a pixel in the image. Okay, so what was this extra line here, CMap equals grays? Now that is just to tell the imshow function how we want to go from whatever the integer or the float happens to be in that array to a color. And the map grays tells it that we want a grayscale image, so an image that is black and white and then all versions of gray in between. What that color map does is it takes the maximum value in the array and says that is black. It takes the minimum value in the array and says that is white. And then all the other values in between that minimum and maximum are scaled to be a various shade of gray between white and black. Now, in our particular case, we only have 2 numbers in our array, 0 and 1. So the 0 will go to white and the 1 will go to black. So 0 is white, 1 is black. And that's how we turn that array into an image. Okie dokie. And this is the image that we're going to be able to produce. And we'll see that live in a minute once I've gone through these first few sets of slides. A couple of other lines in the program from the first slide is just to pretty up the image a little bit. So you'll know from whenever you do a plot with matplotlib that you have ticks along the x-axis and y-axis where you can write down what the values are of the x-axis and the y-axis. Now, when we want to look at an image, at a picture, they're not particularly helpful, so we can turn those off. We could also use a different function axis off to achieve the same thing, as well as actually removing the border lines corresponding to the axis. And lastly, we use a function, if we want to save the figure, we can use a function savefig, also from the matplotlib library. And it'll save the figure with the format that we've specified. So if we did figurename.png inside as the argument to our savefig function call, it would save the figure as a PNG figure. Similarly, if we called it figure1.jpg, it would save that figure as a JPEG figure for us. And it will save it in exactly the same folder on your computer where the script is for the Python that you're running. So that the Python project folder in our case. Or if you don't want to save the figure in the Python project folder, you can put in a path name inside this string here, which specifies exactly where on your particular computer you want that figure to be saved. Okie dokie. So just a quick note, if you happen to be running it as a script rather than typing it in the console, you'll know from when you were doing your assignment that when you did a show, plot.show instruction, the plot would show up, and then you'd have to close it for the rest of the commands in the script to run. So what that means is if you close the figure, it's gone. So you can't have a figure show, close it, and then a save fig line after you've closed the figure, because it'll be saving a figure that's not there. And we'll see that a little bit in the example. So let's move then to PyCharm. I'll make it a bit bigger. I want to see the console. Okay. So let's get started on that code that we saw in slide 1. And I'm going to do it in the console, one line at a time, so we can follow along and see what's happening as we write each line. So first of all, I have to import matplotlib. All right, pyplot. Okie dokie, and I'm also going to need NumPy. All right. Now, let's, before I create my two-dimensional array M, which is going to become my image, just wanted to go through just quickly that idea of assigning multiple entries in an array to be a particular value. And I'm going to start with a one-dimensional array just to keep it a little bit simple. So let's see, we have an array of zeros. And let's give it 10. So hopefully you can, no one's complaining, so hopefully you can all see that very well. So A is my NumPy array, a one-dimensional array of length 10, and it's full of zeros. Okay, so we all know if I want to change one of the values in that array to a different number, we can index it by saying which entry you want to change. So for example, if I wanted to change the first entry of A to be a 1, I would write A square bracket to say I'm indexing the array. Actually, the first entry will be 0. And then I want to assign the first entry of that array to be 1. And you can see, as expected, it's done it for me. But what if I want every entry in that array to be 1? So what you might think is to say A equals 1. Let's make every entry equal to 1. Now, of course, that's not going to work. We can see now that my variable A has been redefined as a scalar integer. The definition up here I did to make A as an array is completely gone. Python's completely forgotten about that array, A, and has instead created a new variable, which is an integer, A. That's not what we wanted. However, we can use the colon function that we learnt on Monday and say create all of the columns in A. So take A, take all of the column entries, and because this is a one-dimensional array, that's basically the same thing as saying take all of the entries. So take A, take all of the entries and make them equal to 1. Oops, what did I do? Oh, I forgot to make it an array again, excuse me. So there's my array A. Let's confirm I've got my array A. Now let's make all of my entries of the array equal to 1. And there you go. Now we can also use the slicing that we saw on Monday to do a similar thing, but with a subset of the entries. So let's make the entries from 3 to 5 equal to 2. And there you go. So that's entry 0, entry 1, entry 2. So entry 3, 4, and 5 are all equal to 2. Now that's what we're going to use now for our example, but in the case of a two-dimensional matrix. So let's go to the two-dimensional matrix, as two-dimensional array now. So I'm going to call it M. I'm going to use NumPy again. And now I want a two-dimensional array. So I'm going to have to specify, use an array to specify each of the dimensions. So the first dimension is 10, 10 rows. The second dimension is 10, 10 columns. So there is my matrix M. Okay. Now I think in the example, did I do it? I did it as a matrix of ints. So there we go. There's my 10 by 10. I'll make this a bit bigger. There's my 10 by 10 array full of integer zeros. Okie dokie. So now we can do the bit where we create the cross in the array. So what I want to do is I want the middle rows, and which in this case are rows 4 and 5, and I want to set them to 1. So I want rows 4 and 5, or 4 to 6, or I could also do 4, 5 like this. And I want to set them all to 1. There we go. So I've set the middle rows to 1. Now I'm going to set the middle columns to 1 too, like we just saw. I'll do it the other way. This time I'll do it using slicing. So 4 and 5 means I need to put in the range 4 to 6, remembering that in Python, we always specify the start row or column and 1 plus the final row or column. Okie dokie. So there is my two-dimensional array M with the cross function that I'm looking for. Now, all we need to do to show how this array is represented as an image is to use the IMShow function, which is inside the matplotlib pyplot module. So let's do that. So we want to show M. Now, if I just did M without telling it which color map I want to use, it will use the default color map. But I don't actually want the default color map because I want a black and white image here. So let me specify. There's a whole lot of different color maps, and you can Google it to find one that you like. We'll just do black and white or grayscale for now. Oops, let me get that picture. So there you go. There is my figure of an image which has a cross in it. Now, it's a little bit hard to tell, but every pixel in that image is an entry in the array M. So let me show you by, say, picking an entry. Let's pick entry 1, 1, and we'll make it black as well. Where did that image go? There we go. So you can see that this is a very blocky image because there's only 10 by 10. So there's only 100 pixels in this image. But this particular pixel, I just changed it so that it was black. And you can see that that pixel on the image is now black. Okay, let me change that back. Okay, so there's my image of the cross. Now, it doesn't really make sense to have these values here on the x-axis and the y-axis, because this is, we're using pyplot to show an image rather than to show an actual plot. So let's get rid of those. So those things are called ticks, and the x ticks means the ticks along the x-axis, and this empty array here means I want nothing there. You could also use that to change the ticks as well, change the value of the ticks if that's what you wanted to do. You can use the same function x ticks. But what I've done is just gotten rid of them. Okay, now let's do the same for the y ticks. Oops, that's not what I wanted. There we go. So you can see we've done that. And the other option is just to turn the axis off. And we're going to tell it to turn the axis off. And here we've just gotten rid of the axis altogether. Okie dokie. Now, inside the Python console, when we do a plot command inside the Python console, the figure shows up automatically. We don't have to do a plot.show. So that means that the figure's there. I haven't closed it. It's open. So now I can do I can save my figure. Sorry, plot. And that function that I'm going to use is helpfully named savefig. And let's call it as toy example and PNG file. You can use whatever you like. Oops. Make sure it's a string. Okay, so it saved it and it's inside my directory. And in fact, it's now, when I did this previously, I opened it up and saved it in the lecture slides. So you could see it in the lecture slides. Okie dokie. So that is how we turn a two-dimensional array into a black and white image. We can also use three-dimensional arrays in order to create a color image. So we'll see how to do that next in the next part of the lecture. Before I do that, is there any burning questions that anyone has that you'd like to put in Discord covering any of the things I've done so far about taking a two-dimensional array and interpreting it as a black and white or grayscale image using Python? Nope, no questions. That's okay, that's great. Let's move on then. Before I move on, this is just really a side note because I noticed with the assignment that a lot of people were asking how they can create multiple plots rather than one at a time and closing them one at a time to run the rest of the code. Okay, and the way you can do that in Python, both for traditional plots and also for the images we're working with today, is to create a new empty figure using the figure function. So you'd write plot.figure and it would create a new figure object, and then you do your IM_show or your plot or however you want to create that particular figure. And then when you move on to the next one, you have a new figure command and it will create a new figure. It won't overwrite the old one. So you can have multiple figures being created. And then at the end, when you've created all of the figures and you've run all of the code, then you do the show function, the plot.show, to show them all at once. And then at the end, you do have to close them all to keep going, but it's a lot easier than popping up one, closing it, running some code, popping up the next one, closing it, and so on and so forth. So just a little tip. And it works for all of the types of figures that you can create with PyPlot. Okay, so I've had a question, which is a pretty good one. How do you change to other colors? And I will address that. I assume you mean with the two-dimensional array, so let's do that. Okay, so here is my matrix M. And remember I said that with the particular color map I am doing, I have mapped one is mapped to black and 0 is mapped to white. But actually, it's the maximum value that is mapped to black and the minimum value is mapped to white. So if I wanted to turn this into a grayscale image, I would just have to create another integer that wasn't 0 or 1. So let's suppose that I don't know, let's do row 3. Let's make it 2. So now you see I've got 3 values in my array. Let's make it symmetric and make it tidy. So what's going to happen now when I print out this two-dimensional array is that 2 is now the largest number in the array. So that's going to be mapped to black. 0 is going to be mapped, is the smallest number in the array. So it's going to be mapped to white. And 1, which is in between those two things, is going to be mapped to a shade of grey in between those two things. So when I do this, so I'm using the exact same color map before, but I have different values inside my two-dimensional array M. I get this cross. Not very pretty, but you can see that the rows, the 4th row and the 4th row from the end are black. The others, which were black before, which are value 1, are grey, and the zeros are white. And with the color map, you can actually play around with that and then have different mappings. You can make your own color map actually, and you can map each number in the array to whatever color you like. That is a possibility. But a better way to do color images is what I'm going to show you in a moment, which is to use a 3-dimensional array. Okie dokie. So let's create a color image now using a 3-dimensional array. So you can think of a 3-dimensional array in this case as a 2-dimensional array where again the rows and the columns are the pixels of the image, but each entry is now itself an array of 3 values. And those 3 values are the values which specify the RGB or red, green, blue color code for that pixel. So if you're not familiar with it, an RGB color code specifies for every single color you might want to use, you say how much red is in it, how much green is in it, and how much blue is in it. And then you mix that amount of red, green, and blue, and you get the color that you want to produce. So for example, if you want pure red, you give the maximum value for red, which happens to be 255, and you say you want no green and no blue. Alternatively, if you'd like a green pixel, you say, I don't want any red, I want the maximum value of green for this pixel and no blue, and so on. And then so a shade of purple will be a mixture of a bit of red and a bit of blue. So this would be the RGB code for purple. Okay, so when I specify my image now, I'm going to specify as a 3-dimensional array where the dimensions are the rows, the columns, and then the 3rd dimension only is length 3, where I specify the RGB values in itself in an array. So that's how it becomes a 3-dimensional array. Okay, let's have an example. So I'm going to do the same toy example of a cross before, but now I'm going to specify it using some colors. So the first line now is I'm still creating an array of zeros, but now it's a 3-dimensional array, not a 2-dimensional array. So the first dimension is 20, the second dimension is 20, and the third dimension is 3. And I'm going to create an array of integers. And I'm going to make the all of the values in the array red. And then I'm going to change some of the values, so a subset of the rows and a subset of the columns to be purple. Just in case you haven't seen it before, this is just a space saving method where I've actually got 2 lines of Python code on the same line with a colon separating them. So when it's run, they're treated as separate lines, but when it's written, it's all on the same line, which I actually did in this case just to save a little bit of space. So that's how I'm going to create a color image using 3D arrays. Now, I'm going to use the same function IMShow. And before, when I used IMShow, if I put in a 2-dimensional array, I had to let it know what color map I wanted it to use. So which values in the array went to which colors. But if I give it a 3-dimensional array, specifically a 3-dimensional array where the third dimension is size 3, it knows straight away, or it assumes straight away, that I'm giving it a color image where the values in that 3-dimensional array, each of the pixel values in that 3-dimensional array is assumed to be RGB. So if I do IM show with a 3-dimensional array of this type, it automatically will assume I'm defining my image using the RGB notation. Now, there's actually 2 ways you can do that. You can describe your matrix M as an integer matrix where you use each pixel, you describe the RGB using those numbers between 0 and 255, which is probably the way, if you are familiar with RGB color scale, that's probably how you're most familiar with it. But there's also an alternative where you can define a float, an array of floats, and each of the RGB values are specified by a float between 0 and 1. So again, 0 means we want none of that particular color, say none of red, and 1 means 100% of red. So 1 is equivalent to 255, and then it scales linearly in between the two. So 0.5 would be half as much red as if I had 1. Okay, so 2 choices. You can either specify as integers between 0 and 255 or floats between 0 and 1. Either is fine. But if you do put in an integer bigger than 255, it will automatically assume, crop it back down to 255 because there's no value greater than 255 in the RGB color scale. And similarly, if you have an array of floats and you put a number bigger than 1, it's just going to assume that it's 1. Okay, so if you want a particular color and you don't know what the RGB specification is for that color, it's easy. There's heaps of color charts or color pickers online where you can pick the color you want and it'll give you the RGB values, or you can put in some RGB values and it will show you what that color is. One particular one that I've seen, not saying it's any better or any worse than any other, but there's a link there for one if you want to go and play around with colors. Okay, so let's do that as an example. Don't need that figure anymore. Okay, so inside the Python console again. Now I'm going to create a new matrix. I'll overwrite the old one, so that's fine. But now it's a 3-dimensional matrix. Oh dear. That's interesting. Oh, is it because I deleted the image? Let me just get out of presentation view for a minute. Okay. I'm just going to re-import, apologies everyone, importing matplotlib. And NumPy. Okay, let's see if I can go back to presentation mode. We'll get up. Okie dokie. Apologies, let's get back to it. Now I'm going to create my 3-dimensional array using the NumPy zeros function. So I think I said I want it to be a 20 by 20 array this time for no particular reason, just because I can. But I want it to be an array of integers because I'm going to use the 0 to 255 array of integers where the 3rd dimension has length 3. So I've got a 3-dimensional array M of integers. And let's take a look at M. So 3 square brackets here, 3 dimensions, and it's got 20 rows, 20 columns, and then each of these, 0, 0, 0, 0, 0, 0, 0, 0, is the values of the pixels. Okie dokie. So let's start off by setting all of the pixels equal to, what color did I want? I wanted red, didn't I? Okay, so all of the values in M now, every single one of them is going to be 25500. Now, I'm going to put a cross in. So I need to make, I think it was 8 to 11, rows 8 to 11, all of the columns in those rows, all of those entries I want to be equal to the length 3 array, 65, 0, 125. This is just some particular shade of purple. Now I'm going to do the same thing, but now with those columns. So all of the rows for columns 8 to 11, I'm going to make those purple as well. Okay. So you can see up here on the right, I have my 3-dimensional array M of size 20 by 20 by 3. And I can turn that into ask Matplotlib to turn that NumPy array into an image. What did it do? It's PLT, not plot. So plot.imshow M. Let me pull that across so you can see it. And there is my color picture of my cross. Oops, my cross is non-symmetric. Let me fix that. I want to go up to column 11, so that means I need to specify a range. Okay, that's better. Okie dokie. So there is my color image, which I have created by creating a 3-dimensional NumPy array and using my knowledge of the RGB color scale. Excellent. So are there any questions about what I've done up until this point in terms of creating color images using NumPy to create the image and using Matplotlib to display it? Okay, so what I'm going to move on to now is just another example of how to do that. And this example was inspired by some of the code that was written in the Discord channel in the Run My Code, where one of the students, Tasneem, came up with a great piece of code to plot a dartboard. But she was actually plotting a dartboard using the plot function one point at a time. So I've taken the inspiration from her code and shown how we can do the same dartboard, but this time by using a 3-dimensional array and specifying the colors in exactly the same way, but specifying them by changing the values of the entries in that array. This is the full code. So I've defined it as a function, actually because I wanted to fit it all on one screen, but also to show you another examples of functions, because we saw those a few weeks ago. So here's my function. I'm calling it dartboard array. All I'm doing in this function is deciding what color each pixel in my array M should take. So I start off first of all by creating my array. So M is np.zeros, and it's an n by n array where I'm going to allow the user to select any value of n they like, but I'm going to make it square. So it's going to be n by n, and then it needs the third dimension has to be length 3 because it's an RGB image. And it's in this case, it's going to be an integer 3-dimensional array. Now, like we saw on Monday, I'm going to loop over each row using the loop index R, the loop value R to index each row. And I'm going to loop over each column using the loop index C for each column. So for a specific pixel or a specific entry in my array M, I'm going to know which row it is and which column it is. Now, because I want a dartboard, which means I want the colors changing depending on how far out you are from the center, I need to define where the center of the dartboard is going to be. So I'm going to ask the user to tell me which row, what is the row index for the center of the dartboard, and what is the column index for the center of the dartboard. So it could be 3.3 or 10.10 or 10.15 or wherever you want the center of the dartboard to be. Okay, and then what you want the radius of the dartboard to be. So I know I have that piece of information passed into the function. So having that information, the size of it, where I want the center to be and what I want the radius to be, I can now figure out what color needs to be at every pixel of my image. So every entry of my array M. The first thing I need to do to figure out what color this particular pixel should be is to figure out what the distance is of that pixel to the center. And if I want to calculate the distance between a particular pixel and another particular pixel, which is the center, I need to use the Euclidean distance, or another way of saying that is the straight line distance. And I do that using Pythagoras' theorem. So for all of you who asked your maths teacher in high school, when am I ever going to use Pythagoras' theorem? Here we go. We're going to be using it because it's very useful to calculate the distance between 2 points where those points are defined on some kind of square array. All right, and then the rest of this code just basically says, depending on how far this pixel is from the array, these are the different colors I want it to have. So if it's very close into the center, it's so a tenth of the radius from the center, I want it to be green. For the next tenth of a radius, I want it to be yellow. Moving out, if it's further away from the center, red, blue, and black. And then when I finish that, because I've looped over every pixel in the array, I now have a color for every pixel in the array, and I'm going to return the array M from my function. So that's what my function returns. So now to call it, I need to specify what I want N to be. You could pick anything, let's say 500. I specify my center point. In this case, I want the center to be exactly in the middle. So I'm saying the center point is halfway along the array, both in terms of the rows and columns, and I've picked a radius, which again is half the size of the array. So I actually, in this case, want my dartboard to go all the way to the edge. Call my function and then print it out. So let's have a look at that in Python. So now that's a pretty big function. So I'm not going to type that in the console. Instead, I'm going to use a script that I already prepared earlier. Let me see if I can get that. That's not it. Where is it? Here we go. So here is the script that we just saw. It's literally the same code that we just saw in the slide. It's got the function dartboard array. It's going to specify some values that I want for where the center point is, what the radius is, and then I'm going to call the function, which will create my array, my 3-dimensional array M, and then I'm going to plot it to just show me what this 3-dimensional array looks like as an image. And then finally, because I'm writing this in a script now, not in the console, I'll need a plot.show so I can actually see that image. So I don't, okay, I might have to go out of to run this particular one. So there we go. There is my dartboard image that I have just created using some simple Python, some NumPy arrays, and the matplotlib library just to present it up as a figure. Okie dokie. Okay, so there's a great question on the Discord, which I will answer by just one moment, going back to the right view. So the question was, when I do something like M, so I have a three-dimensional array M, but I'm saying that I want all the rows and all the columns. So the question was, what does it assume the third dimension to be? And I think you're referring to the question where I did this, something like this. So 255, 0, I think I did for red. So it doesn't have to assume anything about the third dimension because I'm actually telling it. On this right-hand side of the equal sign, I am telling Python that the third, for each of the rows and each of the columns, this is what the entry is going to be. So I'm actually specifying that that third dimension is going to have 3 values. So hopefully that answered your question. And when I defined the array also, let's see what happened. I don't know what the answer is going to be to this. If I tell my tell that I want my every pixel to have a length 4. It's not going to let me. So originally, when I defined that array, I'll see if I can pull up that equation. It was m equals, it was numpy dot zeros. I'll type it again. So when I defined that array, I defined it to have, I'm not sure if it was 20, 23. So when I defined that array M, I defined it so that I said that the number of rows, the length of the first dimension or number of rows was 20, the length of the second dimension or number of columns is 20, and the length of the third dimension was 3. So I specified that to be the case when I defined M. Now I could create a new M where I specify that actually that third dimension has length 4. Then I could do this. M, all the rows, all the columns. I want the entry to be, I don't know, 1, 2, 3, 4. So I want it to be an array of length 4. Now, hopefully it'll let me do that this time because my original array M this time had length 4 for the third dimension. So if I look at M, you can see all of my entries are in fact 1, 2, 3, 4, like I wanted. So hopefully, yep, sounds like that answered your question. Fantastic. That was a good question, by the way. Okie dokie. Now, last thing I'm going to do in this lecture, so far we have created all the images. So we have created the images from scratch by creating the NumPy from scratch. But you can also, of course, work with other people's images by importing them in. And we're going to use the matplotlib module image to do that. There are lots of different options, and we may see some different ways of working with images in week 10 when we look at images in more detail. But just for today, we're going to call in a image I got off the internet called Stinkbug, and we're going to show it. And the benefit for us with using the particular image module is that the image is automatically read in as a NumPy array, which makes it very easy for us to play with it. And this is what that particular Stinkbug image looks like. So in this particular case, they're using, it's RGB, so this is RGB, but they're using the float version where all of the numbers are between 0 and 1. And so you can see this is a specific type of grey, which is slightly closer to white than to black. So this is what these numbers mean when you take a look at the three-dimensional array that we're going to pull in. So let's do that quickly. Now, where was I? Okay, so it's called stinkbug.png. Did I? Actually, I'll need to import that first, won't I, before I can use it? Import. Oh, let's just call it, forget what I called it, MP image. Okie dokie. So we'll import that particular module because we're going to use it now. And then what I'm going to do, I've already imported PyPlot, so I don't need to do that again in the console. So now I'm going to do this one, which is imread. And the function I want, imread. And then stinkbug.png. Okay, so I'm going to load in. Now I have that stinkbug.png image inside the same project folder where this project stores all of its Python code. So that's how it can read it in just with a name. If it was stored somewhere else, I'd have to put in a path, but keeping it easy. Let's have a look at what we've got. So there is the array. It's very big. There it is, with all of the values in it for all of the pixels. Now I can have a look at what this image is. Now I just need to, because it's a color image, I just need to put in image. I don't need to tell it the color map because the imshow function will automatically know. And there we go. There's my image of a bug, a stink bug. Fantastic. And now that I've got that three-dimensional array in, I can play around with it. I can change the pixels. And then I can do sophisticated things like filtering or masking or rotating. All of the cool things that you can do with images, I can now do by working with the NumPy array. And then when I've finished and I've got the NumPy array modifying the image as I would like, I can then show it, or I can in fact save it as a new image, stinkbug2 or stinkbug edited, and have that forevermore. So we can do some really powerful things now that we've got these basics of representing an image as a three-dimensional array. Steve, you're right. This is a RGB image, even though it doesn't look like an RGB image, it looks like a grey image. And that's because every single pixel in this image has been specified so that it's actually a grey color. So they've deliberately chosen each of the pixels there to be a grey color. Okie dokie. And you can see that with these numbers here. So before I go, I just want to show you, leave you with a couple of pictures. Now these are some pictures of a fern, and hopefully Brenton is contemplating making this your job in the labs next week to produce these beautiful images. So that's something to look forward to. Thank you everyone today, and thank you for bearing with us on the chat. It was fantastic, and see you all next time.